Welcome to Big Data Now. Today, we are exploring Apache Spark, one of the most powerful frameworks for distributed data processing. Organizations today deal with massive volumes of data, requiring frameworks that can process, analyze, and transform data efficiently. Apache Spark has emerged as a leader in big data computing due to its speed, scalability, and ability to handle real-time and batch workloads. In this video, we will explore what Apache Spark is and why it's important, how Spark's architecture enables distributed data processing, key components like RDDs, data frames, and datasets, how Spark executes jobs efficiently using DAGs and cluster management, and real-world examples from ETL pipelines to machine learning with Spark MLlib. By the end of this video, you will have a deep understanding of how Apache Spark works and how to use it in real-world data engineering projects. Let's get started. What is Apache Spark and why is it important? Apache Spark is an open-source distributed data processing engine designed for fast, scalable computing. It is used for batch processing, real-time streaming, machine learning, and graph analytics. Unlike traditional processing frameworks like Hadoop MapReduce, Spark processes data in memory, making it significantly faster for many workloads. Apache Spark provides a unified data processing framework that supports multiple workloads, including batch processing, real-time streaming, machine learning, and SQL queries. It runs on clusters of machines, distributing tasks for fault tolerance and parallel execution. In-memory processing allows Spark to store intermediate results in RAM rather than writing them to disk, which improves execution speed. Spark integrates with various data storage solutions, including HDFS, AWS S3, Azure Data Lake, and NoSQL databases like Cassandra. Now that we understand why Spark is so powerful, let's explore how its architecture makes distributed data processing efficient. Example 1. ETL pipeline with Apache Spark. Let's say we have raw sales data in CSV format stored in AWS S3 or Azure Data Lake, and we need to clean, transform, and load it into a data warehouse like Snowflake. We begin by reading the raw data with Spark's data frame API. The following code initializes a Spark session and reads the CSV file. To prepare the data for analytics, we compute total sales by region and load the transformed data into Snowflake. This example shows how Apache Spark automates ETL workflows in distributed environments. Now let's move to a real-time streaming example. Example 2, real-time data processing with Spark. Apache Spark also supports real-time data streaming, making it ideal for fraud detection, IoT analytics, and event-driven architectures. For fraud detection in banking transactions, we can use Spark streaming to process real-time transactions received via Apache Kafka. The first step is to read the Kafka stream. Next, we detect suspicious transactions. Finally, we write alerts to a NoSQL database. This real-time fraud detection pipeline demonstrates Spark's ability to process and analyze streaming data at scale. Apache Spark also includes MLlib, a machine learning library for scalable AI model training. To predict customer churn using logistic regression, we first convert the dataset into feature vectors. Next, we train a logistic regression model. By using Apache Spark MLlib, organizations can build AI models at scale, leveraging distributed computing. Apache Spark is a powerful framework for distributed data processing, enabling real-time analytics, machine learning, and scalable ETL pipelines. If you found this video useful, subscribe to Big Data Now for more insights on AI, big data, and ETL architectures. Share your thoughts in the comments. How are you using Apache Spark in your data workflows? Thanks for watching, and see you in the next video.